Hey guys, our project is called Stock Predictor 101. I'm Clement.
I'm Haniel.
A bit of recap what we're doing. So we're trying to predict stock prices based on indicators, historical prices, and S&P 500 prices. And so what we're doing is basically technical analysis. So we believe a neural network is the best choice for that. So I'm going to talk about what we've accomplished so far. So for compiling data, we use AlphaVantage to get our data, and for every stock we get like the following things. For example, price, we have the opening, closing, and adjusted price, and that means that for each stock we have like 30 features. Data processing, so we have to make sure that data is in temporal order from earliest state to latest. And we also scale the data using sklearn, min-max scaler, and we have to see Excel scale so that we could transform data back after prediction. We also split the data in a segment of 60 consecutive days, and that's just for us to feed into the neural network. So the type of neural network that we're using is recurrent neural network, because recurrent neural network has the ability to retain knowledge from the past, and that is good for us because we believe that stock prices will not be determined not only by the day before, but also by a few days beforehand. And they can do that because they will feed the input value along with the results from the previous basic layer into the current layer, and they'll keep doing that. So that therefore, at every stage in time, they would have knowledge of the previous layers and previous knowledge.
We implemented long short-term memory with TensorFlow. TensorFlow Keras allows for us to process sequential data. So as we mentioned before, our X will be a batch of the trailing 60 days, and our Y label will be the price for the data on the following day. So we have all those features for many stocks in one row, and then our batch will contain all of that for 60 days, and then we'll predict upon that. So we build our network with an input layer that initially takes in all of our inputs, and then we add dropout after each LSTM layer. So the first LSTM will take in all the inputs from the stock data, and then the dropout will randomly take out nodes so that the neural network doesn't become too dependent on one node. So we have additional layers, and they have different numbers of units within each layer, and the dropout percentage for each node can be different. So we have, at the end of this, we have the dense layer, which outputs the stock price, and this is a many-to-one layer, many-to-one neural network. And we implemented our network such that we can change the different units or the different nodes for each LSTM layer and the strength of the dropout layers. So looking at our early results, we have split the data by date. Our training data was stock price for Apple, and we also added in Google and the SP 500 and different features. And we looked at that from 2004 to 2019. And the parameters we have for our model are the different layers. We used 4 LSTM layers, and we have dropouts for all of them. And here we have an example of our testing. And this is for 25 epochs and a batch size of 100. And we use our optimizer AdaBoost, which is a mix of SGD and Atom. And we can see that there's a large decrease in MSE as epochs increase, and at some point we optimize for the number of epochs. Currently we are dealing with GPU limitations, and we are working our best to solve that. And so when we fit the data onto the price, we see that in blue is the Apple predicted adjusted stock price and the actual Apple adjusted stock price. And what we found was our MSE with 0.06.
So I'm going to talk about some challenges that we face. So alpha industry ABI meant that we only can have 5 requests per minute and 500 requests per day. And for each stock, we need 10 requests. So that really limits our ability to scale up and get more stocks in our data. Also, we look at PyTorch, but that didn't really work out for us. So we moved to TensorFlow. And also a challenge for us is that we never really done this before. And so we have to learn like from scratch about recurrent neural network and about the various types of recurrent neural networks and also implementation with TensorFlow. And also we have a lot of features, and also that also means that we have a lot of hyperparameters from recurrent neural network, and that's just a lot of things for us to tune and just make it nice and polished. What we do next. And so as I say, we have to look at alternatives to scale up our ability to get more features and more stocks into our data. And so we also plan to do that in the near future. We also want to fine-tune the hyperparameters and parameters so that we can get a better result. And we can also try out different recurrent neural networks, for example, gated recurrent units. From our research, it seems like it's a really good fit for predicting stocks. And that's it. Thank you so much.